Hey everybody, this is the second video in the counting chapter, and this is the official fundamental counting principle. So I took this out of, it's not even the textbook we're using, it's a one, well, never mind, it's an older one that I prefer, and I still don't like this because this is what math people do, and I get it, but I don't like it. If a series of n decisions must be made, and if the first decision can be made in x1 ways, the second decision can be made in x2 ways, and the third decision can be made in x3 ways, and so on and so forth, until the nth decision is made in x to the n ways. Then the number of different ways in which all of the n decisions could collectively be made is x1 times x2 times x3, and so on till x1, till xn. Yes. And 90% of the people have no idea what that means. And that's why I don't like our math textbooks. Well, the ones we have right now. Never mind. I'm not going to rant. Okay. So here's Joanne's translation of that. It's the same thing. I understand why they do this. They want to make it generalized. So it's not specific to any set of numbers or any specific questions. But still don't like using it. Number one, I think I said this twice in the previous video. Read your question carefully. You have to figure out how many things you need to decide. Once you do that, you draw a blank for each decision and label them underneath, which is also what we did in the first vision. Write the number of choices for each decision in the appropriate blank, multiply your numbers. Okay. Once you see this, you're going to go, oh, all right. All right, so how many outfits can Al wear if he has 5 pair of dress pants, 4 dress shirts, 3 ties, and 2 pair of shoes? We're going to assume, I should have written it in the question, but he is going to wear pants and shirt and tie and shoes. He's going to wear all of them. Okay? So, and one of the things to do to make this work is imagine that you're Al. What do you got to do? Well, order doesn't matter that much, but first of all, he's got to figure out which pair of pants he's going to wear. And then hopefully he's going to figure out what kind of shirt. Not going to be lazy. And then he's going to figure out his tie, and he's going to figure out his shoes. Oh, for those of you that are fashionistas, we also assume that everything coordinates. Okay, so read carefully. What do you have to decide? And we draw a blank. So one for his pants, one's for shirts, ties, and shoes. And then we go back and we fill in how many choices. So pants, he's got 5 pair. And shirts, he's got 4. Oh, he's got 3 ties and 2 pair of shoes. Just for the record, I'd like to tell you that I was trying to be tricky so that you don't just always multiply any numbers you see, and I wrote this one out, but I have no idea why. I was just typing. So now you just need to multiply. So 5 times 4 is 20, times 3 is 60, times 2 is 120. There you go. So he's got 120 different outfits. Ladies, I don't know if you've ever been to, I know Ricky's does it and a couple other ones. They'll put these ads out and it's like 150 outfits with these 10 simple pieces. This is what they're doing. If everything coordinates, then you just multiply the number kind of each piece, and ta-da, you get this huge amount of different outfits that you can have. Okay, here we go. Number 2, a restaurant has a complete meal deal for $23.99. It includes an appy, a main, a side salad, and a dessert. If there are 6 appies, 5 mains, 2 salads, and 4 desserts to choose from, how many different meals are there? All right, so first we need to decide on our appetizer, and then we need our main, and then we need our side salad, and we need dessert. Okay. And then we just go through, well, how many appies? We can choose one of 6. So if we were doing this as a tree diagram, we would start out with 6 branches like that, and it would have, so this would be appy 1, 2, 3, 4, 5, 6. And then you would go got 5 mains, so then this wouldn't have 1, 2, 3, 4. Okay, my diagram's already ugly. I'm going to stop. But that's essentially what we're doing, is we're just multiplying. So 5, 2 salads, and 4 desserts. So that's 30, 60. That should be 240. I'm too lazy to find a calculator right now. Okay, I suspect you should certainly be able to do that question. Sorry, do the rest of them. So pause the video, do the questions, and then come back. Alrighty, here we are. Okay, so the vintage phone offers several basic models of phones: princess, a hamburger, wall, and a desk. Each model can come in green, beige, red, black, or white. And each one can be rotary or push button. Notice vintage. I'm sure some of you have never used a rotary phone. I was on a party line. Ask probably your cookum what that was. How many different phones do they offer? All right, so how many blanks do we need? We need, this is our model. And then we can do color. And then we can do, I don't know, I was going to call it R for rotary. It doesn't matter too much what you call them. But it is, for me, it's important to put something under there, especially when I go to look at it. Like you do it, I look at it. So I know where the numbers are coming from. So we got models. So we got princess 1, 2, 3, and 4. Each model can come in 1, 2, 3, 4, 5. And one can be rotary or push button, so that's 2. So 4 times 5 is 20, times 2 is 40. Are you liking this? I think you should be. I just realized I moved away from the mic, so I'm sorry if my voice keeps changing on you. All right, in a 7-horse race, how many first, second, and third place finishes are possible? Okay, so we got to be careful. How many things do we have to decide? What are we going to win? Well, we need to figure out, or the horses, I guess, figure out who comes in first, second, and third. So we're making some assumptions on this question. We're going to assume that all the horses are equally good. So horse number running, how many at the very start theoretically could come in first? Well, I would think there'd be 7 horses. Now we have to think, how many horses can come in second? Is it 7 horses? Oh, I wish you had a camera, because I'm just like seriously, that doesn't make any sense. So once that first place horse crosses the line, how many are left? There are 6. And then you should be able to figure out the next one, which would be 5, right? So sometimes the numbers come down, sometimes they're all over the place. It really depends on the question. That should be 210, but I don't know. 7 times 6 times 5. Yep. Okay. So assuming that all the horses are equally good, and it's just random which placing you make. Oh, sorry, I guess I should read the question. SIAT is planning student breakfast at the end of the year. Students can have plain blueberry or Saskatoon pancakes. Okay, so this is my pancake choices. I might as well write 3 while I'm at it. They can choose one of 5 different toppings and can have coffee, tea, apple, or orange. So our drinks, now I lost count, 1, 2, 3, 4. All right, and if we multiply through, that should be 60. And you know what? I'm going to make number 6 a bonus question, because if you watch the video, I'm pretty sure this question didn't make it onto, I don't know if it made it onto yours or not. I think I got rid of it. But make up your own question, email it to me, and I will give you some bonus marks, especially if you have the right answer. Okay, that is the end of this Introduction to Fundamental Counting Principles.